No. All right. So what Marissa was trying to convey up here was where we get this formula from to find the sum of all of the angle measures inside of any polygon. Okay, we talked about in the last chapter that the sum of the angles in a triangle is 180. Right? So we're going to use that idea to find the sum of the angles in any polygon. Right? And at the right side of your paper, we've got a list of the names of polygons with 3 through 12 sides, and then really after 12 sides, we just call it like a 13-gon or a 14-gon or a 15-gon. Okay?
100-gon.
A what?
100-gon.
100-gon, sure, 100-sided shape. Okay? So, I mean, you guys have seen most of these names before. Okay? 3 sides of a triangle. Any 4-sided shape is quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, and dodecagon. Those ones might be ones you're not quite as familiar with. But at least like the first, up through 8 or 9 sides, I'm sure you've seen before. So this formula, what this is saying, or what this paragraph that Marissa read to us up here is saying, is, well, if I have a triangle, I know that the sum of those 3 angles is 180. If I have a 4-sided shape, I can connect vertices to create 2 triangles in it. So a 4-sided shape, I can create 2 triangles. To get the sum of all of the angles inside, I would just add up 180 plus 180. Okay, so a 4-sided shape has 2 triangles.
So like, wait, you like square. So that's square. And like all angles 90. Does that equal circle 60 though?
So, yes, I mean,
It's really bad.
it's a little bit,
So a square equals a circle.
not quite. So what the difference between a square and a circle, I mean, obvious when you look at it, but what we're saying for the measures, right, these 4 angles would all add up to 360 degrees. When we're talking about a circle, the reason we say a circle is 360 degrees is we're talking about all of the angles starting at the center. Okay, so if I were to draw a bunch of angles starting here, those angles would add up to 360 degrees. Right? Like, I mean, I could draw a bunch of 90-degree angles here, or I could draw 180. Right? Those are the angles that add up to 360 in a circle. Okay? So, and if I draw a 5-sided shape here, 3, 4, 5, and I connect vertices like that, I create 3 triangles. Okay, so 5-sided shape, I get 3 triangles. 5 minus 2, 3 triangles. Each triangle has 180 degrees, so 3 times 180 would be the sum of all the angles in a pentagon. So this formula, number of sides minus 2 times 180, gets me the sum of all of the interior measures of a polygon.
Why would minus 2?
Because of what I just showed you. So a triangle has 1 triangle, 3 sides, so 3 minus 2 is 1. 4-sided shape, I can create 2 triangles. 4 minus 2 is 2. 5-sided shape, I can create 3 triangles. So 5 minus 2 is 3. We could keep going, right? But if I draw a 6-sided shape, I take one vertex and connect the non-consecutive vertices. So non-consecutive just means the ones that aren't right next to it. Right? So if I take and draw lines from here to here and here to here, those are the 2 non-consecutive vertices to that point. So that's just explaining where this formula comes from. Right? So if I've got a 13-sided shape, how would I find the sum of the measures? 11 times 180. So what is 11 times 180? Yeah. 1380? So if I were to add up all 13 angles on the inside of any 13-sided shape, right, no matter what that shape looks like, I would get 1,980 degrees. Now, there is another word in here, convex. What does convex mean?
Well, concave.
Yeah, essentially. So concave means a shape caves in on itself, right? So an example of a concave shape would be something like that. No. So that's why they specify convex. Okay, so this stuff only works for a convex polygon. And that's in our definition here as well. So if we see something like this, where a piece of the shape caves in on itself, that's not convex. This would not apply to something like this. Okay?
So you need
Yeah.
that triangle. The triangle that like specify is like that. Or no?
No. This is an example of a concave polygon where part of it caves in on itself. Convex means that we don't have any pieces that are caving in on itself, right? So something like that. Okay, this would be an example of convex. And for us to use this formula, our polygon has to be convex. This formula would not apply to something like this.
Is there a formula for that?
No.
Or do we have
No. I mean, you just have to know that this formula only works for convex. Okay. So, in example 2 here, we are told that the measure of an interior angle of a regular polygon is 120. What does regular mean?
It's what you think of when you see like
like
an octagon. It looks like a stop sign.
A stop sign is an example of a regular polygon. Even more specific than that. No.
It's what you think of like
It's a
a
basic.
normal shape.
It's a pumpkin spice basic polygon.
Pumpkin spice basic polygon. So, regular means
Regular.
all sides and all angles are the same. Okay? So, an example of a regular triangle would be an equilateral triangle. Okay? An example of a regular quadrilateral would be a square. All the sides and all the angles are the same. Okay? So, this question says, the measure of an interior angle of a regular polygon is 120. We want to find the number of sides.
Maybe all.
So all the angles are going to be 120. Okay? I want to figure out how many sides it has. Well, to do that, we actually need to think about another formula here. So if I know all of the angles inside of a polygon, add up. Say it again. By original number, you mean not the 120. So if this gets me what all of the angles will add up to, there we go. We're going to take this and divide it by how many sides there are. So dividing by n. So our formula for that is going to be n minus 2 times 180 over n. And in this case, we're saying that this is going to be equal to 120. So I want to solve this equation. How would I solve something like that?
When you multiply so like this, don't you have to get rid of this side sign?
Yeah, we want to.
Multiply it by n. Yeah, that's what I meant.
Right. And if we're going to do that on this side, we got to do that on this side. Okay, so the best option here is to multiply both sides by n first. I cannot just cancel out the n's in the numerator and denominator as it is because I'm subtracting.
But
Right?
it means that.
No, I know what you meant. Yeah. I'm just saying, like, I think somebody said cancel out the n's, which we can't do that right off the bat because I'm subtracting in here. So I need to multiply both sides by n. Okay, if I'm multiplying by n and dividing by n, that cancels out. So I'm just left with n minus 2 times 180 equals 120 times n. Now what can I do? Well,
Take n over.
So, do the other side.
so we probably want to distribute this 180 through the parentheses. Right? It looks kind of weird because the 180 is on the right side, but we're still going to distribute here. So this will end up being 180n minus 2 times 180 is 360. Yes.
So you know how we're the n side, isn't it? N
I mean,
convex. I don't know what I'm trying to say. I'm just like, because when you plug in a number like n,
Well, n is going to be a number of sides, so n is probably going to be a much smaller number than 120. Okay, so now I want to get my n's on the same side of the equation. Since I have my number over here, it probably makes sense to subtract 180 over to this side. Okay, so then I'm going to come over here and finish it out. I've got negative 360 left on this side, and then 120 minus 180 would be negative 60n.
sides and divide by 12.
you look into the side. It's hard to look into the side.
So it's 120.
Divide both sides by negative 60 to get n by itself. You get 6.
All after the hexagon.
So that tells us that a regular hexagon has interior angles of 120 degrees.
How did I feel like I did that?
Maybe it did.
If it's a regular polygon, I don't know, it's square root, right? You can't just square root it for all these things.
Square root what?
120. I don't know.
The square root of 120 would be like 10.9.
What?
The square root of 120 would be like 10.9 something.
Or divided by like whatever is equal. Whatever is all equal, okay?
Yeah, so we just want to find the number of sides. So n is the number of sides. So our answer here is 6 sides. Other questions? Alright, so let's try a couple of these then. Down here at the bottom, the exercises. Right? The first few are just find the sum. So the sum means the total, so that's just this. Then believe in the next section, it says find the number of sides, so like example 2. So let's take a couple of minutes and try some of these. And if you feel like you can try number 10 down at the bottom.
Okay, my thing does not work.
Alright.
My thing doesn't work.
So the answers here. Let's see, this was number 4, 5, 6, and then these aren't on there. Okay, so here's the answers for 1 through 6.
Where's 7, 8, and 9?
So they're not on here. We'll have to go through 1 or 2 of those together here. I changed the note sheet up a little bit, so the answers for some of them aren't on here. Okay, so on the first 3, we're just saying, given a shape, find the sum of the angles. So we're just using this formula. Alright, so a decagon has 10 sides, so I would plug 10 in for n. So 10 minus 2 times 180 gets me 1,440. For the next section, those were like example 2, where we were saying n minus 2 times 180 divided by n equals that angle measure. Okay, so for this first one, we would say this equals 150. For 5, we would say equals 160. For 6, we would say equals 175. And we're solving for the number of sides. So 12-sided shape, 18-sided shape, 72-sided shape for this last one. All right. Any questions on those 6? So yeah, let's look at 7, 8, and 9 first, and then we'll come back to 10. So on 7, 8, and 9, it just says find the measure of each interior angle of a regular polygon. So we know that the sum of the angles is n minus 2 times 180. Well, then if I know all the angles are the same, I just divide by n. So all I'm doing for 7, 8, and 9 is plugging a value of n into this formula. For 4, 5, and 6, I was solving for n. For 7, 8, and 9, I'm plugging a value in for n. So for 7, and I know an octagon has 8 sides, so I'm just going to plug 8 in for n. Alright, so 8 minus 2 times 180 divided by 8, I think gets us 135.
Yeah.
Okay. A pentagon, what is that one? 108.
Yeah.
And then a 15 gon, I don't know that one.
156.
156. What's up?
Wait, so a 15-sided shape at 156 degrees.
So all 15 angles on the inside would be 156 degrees. The n minus 2 times 180 over n.
Oh, I didn't know.
Yeah, never mind. I understand everything. Never mind. I just say.
Okay. Questions? Okay, so then the very last one, we need to first figure out what all 5 of these angles will add up to. Okay, this is not a regular figure. All the sides and angles aren't all the same. So I just need to find the sum of all 5 of these. Well, it's a 5-sided shape, so the sum of all the angles will be 5 minus 2 times 180, which gets me 540. So then, I want to add all 5 of these together and set that equal to 540. So 7x plus 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10 equals 540. 26x plus 20.
Yeah.
Subtract the 20 over. Divide by 26. We get x equals 20. Is that my final answer?
Yes.
Yes. So it just says find x. Questions? Okay, so real quick, we can do the back in 4 minutes because it's a lot easier.
Oh, very good question.
Exterior angles.
It's just the opposite.
Kind of.
It's just the opposite.
This isn't quite as intuitive, but it's a lot easier. Okay? The sum of the measures of the exterior angles, and remember, an exterior angle is just if I extend all of the sides out, I create exterior angles.
Oh, yeah.
The sum, no matter how many sides the shape has, the sum of the exterior angles is always 360. Okay? Whether it has 3 sides or 400 sides. The sum of all of the exterior angles is always 360.
So exercise 1, 2, 3, 4.
Yes. Okay? So the sum of the measures of the exterior angles of a 26-sided or a 27-sided shape is 360 degrees. So now, if I want to find the measures of each individual, you just divide 360 by the number of sides. So we're going to take 360 divided by n. In this case, if we're talking about a hexagon, and remember, this only works for regular figures because I know all the angles are the same. So I'm going to take 360 divided by 6 here and get that each of these exterior angles is 60 degrees. So again, just like the front, this only works for convex polygons. So concave polygons, this stuff doesn't work for. Okay, so the exercises down at the bottom are pretty easy, right? The first one, the sum of the measures of the exterior angles is 360, 360, 360. No matter how many sides it has, the sum of the exterior angles is 360. And then if I know that these are regular polygons, to find each individual exterior angle, I would just take 360 divided by the number of sides. Any questions?
Number 8.
Yes.
Can we get decimals?
Yes. Okay. Any other questions?